In this video, we are going to look at how to solve logarithmic equations. Remember, as you do this, always remember to check for extraneous solutions. We have several methods we are going to use. This method number one is called solving by exponentiation. And when do we use this method? We use this method when we can be able to write the equation given as an exponent. And how do I do it? So we write the equation in exponential form and then use the knowledge of exponents and the fact that if you have the same base, then the exponents will be equal. So let's do example number one. And in this example, I'm going to exponentiate. So 3 raised to 2 is going to be 4x minus 7. And that will, when I write it, remember I'm able to get rid of the logarithm. So I'm going to write 3 squared is equals to 4x minus 7. And all I need to do now is to solve the equation. So 9 is 4x minus 7. And then here I get 4x is equals to 16. And I get x is equals to 4. And make sure you plug it back into the original equation. So if I plug this in, so I would get 16 minus 9 minus 7. So that will be 7. So 3 raised to 2 is 7. If you plug it in and what you get in parentheses is negative, definitely you know that's not a solution. But this one is a solution. Next one, so I write x raised to power 2 is equals to 64. So what does that mean? So x is equals to plus or minus square root of 64, which is equals to plus or minus 8. But what do I know? The base cannot be negative. So I know the only valid answer is 8, positive. So the negative 8 is an extraneous solution. Okay, the next example here, we are going to do the same. So we have 5 raised to x is equals to 25. And remember what I'm doing, 5 raised to x gives me 25. So moving on. So I need a number which I need to raise 5 to get 25. So that's going to be 2. And when I plug it in, I'm going to see that's the answer. The next one here, this is natural log. And to better understand this, we could write this in terms of base e. This is, remember, this is logarithm to base e of x is equals to 4. And then we can write e raised to 4 is equals to x. And then we can simplify that. If you check the value of e in a calculator, raised to power 4, you get x is about 54.6. And again, you can check that into the original equation. Now here, we are going to look at another method. We are going to solve equations containing only logarithms, and this is type 1. And what do we know about this type? If logarithm to base b of m is equals to logarithm base b of n, since the base is the same, m is equals to n. M is equals to n. So what does that mean? This means that 2x, so 2x minus 7 is equals to x plus 10. And remember, to make this decision, I looked at the base is the same on both sides. So it's like the base cancel out. So here, I'm left with this equation to solve. So when I solve it, I get x is equals to 17. And I need to plug that to make sure what I get in parentheses is not negative. Now when I do that, that's going to be 34, so 27. So that's going to be my answer. So the next one, the logarithm is a bit same on both sides. So I have 5.6 minus x is equals to 18.4 minus 2.6x. And then I can subtract 5.6 from both sides. So here I'm just using the algebra, the simple algebra, to solve this equation. And what do I get? So I get 1. This is going to give me, remember here I can add, let me add 1.6x to both 2.6x. And I add 2.6x. And then here, when I simplify all this, I get 1.6x is equals to 12.8. And I get x is equals to 8. The only thing here, if I plug in 8 here, you see I'm going to get a negative value. You cannot get the logarithm of a negative number. So here, that means this is not a solution, so it's extraneous. So here we are going to say no solution, because what we have is an extraneous solution. Now here, we are solving logarithm equations with more than 2 terms. This is type 2 of the previous one we solved, which was type 1. So how do we do this? So here, since I have 2 terms on this side, I need to combine them. So I'm going to combine and write as logarithm to base 2. Since I'm adding, I'm going to multiply is equals to logarithm to base 2 of 18. And now, since the bases are common, here I'm just going to write 6k is equals to 18 and k is equals to 3. When I plug that in, I just need to make sure it doesn't lead to a negative number. So that's the solution. Okay, so here is another one. So again, we combine the left hand side. So logarithm to base 4, and then we have x and x minus 12, and this is going to equal 3. So now here I can use, since I don't have logarithm on the other side, I'm going to use the method called exponentiating. So I'm going to write 4 cubed is equals to 4 cubed is equals to x squared minus 12x. And when I see x squared, I start thinking quadratic. So here, this is 64 is equals to x squared minus 12x. And now I'm going to write x squared minus 12x minus 64 is equals to 0. And all I need to do is to factor it. So here I get x minus 16 and x plus 4 is equals to 0. So I get x is equals to 16 or negative 4. But then I have to check these ones to see which one is valid. The negative one, if I take negative 4 and I bring it here, see, this will be negative. So negative 4 is not a valid solution. So this one cannot be a solution. It's an extraneous one. So there we go. X is equal to 16. Now here we have another one. So I'm going to combine the right hand side. So here I have logarithm to base 4 of 3. Actually, this one is going to be x plus 2, and I'm dividing by 3. And on the other side, I see I have the same base. So let me just rewrite it. Logarithm to base 4, 2x plus 1. Since the bases are the same, I'm going to write them as equal. 2 plus 2x plus 1 is equal to x plus 2 over 3. I multiply by 3 both sides. So we get 6x plus 3 is equal to x plus 2. And then what do we get for x? So x is going to be, I subtract x from both sides. So I get x is equal to 1/5. Negative 1/5. Let me just rewrite it here. Negative 1/5. And then I just need to plug it to see whether I'm going to get a negative. And I see it does work. So that will be the answer.